Here we're going to find the 5 remaining trigonometric functions for an angle theta. We're given that tangent of theta is negative 12 divided by 5, and we know that theta is between pi over 2 and pi. That puts that in quadrant 2. If we let point xy be on the graph of a circle, x squared plus y squared equals r squared, we know that tangent of theta is equal to y over x. Now we have a negative value for the tangent, so we need to determine whether it's y or x that's negative. Since we're in quadrant 2 on our circle, we know that it's the x value that's negative, so we can write this as 12 over negative 5. Therefore our point pxy is equal to negative 5 comma 12. And then we can use that to find our remaining trig functions. First, we're going to need to find the value for r. Since we know x and y, we'll put those values in. X squared plus y squared equals r squared. That's our circle. X is negative 5. Negative 5 squared plus 12 squared equals r squared. And if we solve this for r, we'll get that r is equal to 13. Remember that r is the radius of the circle, so it's going to be a positive value. Now that we know x, y, and r, we'll find the remaining 5 trig functions. We'll start with sine. The sine of theta is equal to y over r. We know that y is 12 and r is 13, so we get sine of theta is 12/13. For cosine theta will be x over r. Put in our value for x, that's negative 5. R is 13, so cosine is negative 5 over 13. Tangent of theta will be y over x. Again, putting in our values for y and x, we'll get negative 12/5. Cotangent, I guess we already have tangent of theta up there. Cotangent of theta is equal to x over y. Plug in our values for x and y. We'll get negative 5/12. Secant of theta will be r over x. Plug in our values, and we will get r is 13, x is negative 5, so negative 13/5. Cosecant theta is equal to r over y. We plug in our values. R is 13, y is 12, and so we'll get 13/12.